There are two types of special right triangles, and in this video, we're going to go ahead and take a look at the 45, 45, 90 special right triangle. Now, a little later in the video, I might try to channel Jerry Maguire. Keep in mind that I have had no formal training as an actor, and it might show. So if it gets awkward, just realize the peak of my acting career was being Mayor of the Munchkins in a 6th grade play. So you've been warned.
This is an isosceles right triangle. When you have two equal angles, you would also have two equal sides. So let's just explore why this works by just saying that both sides are 5 and see what happens. We can solve for the hypotenuse, which we'll just call n, by using Pythagorean theorem. So we end up with 25 plus 25 equals n squared. 50 is n squared, so n is radical 50. You can't see the pattern with that. But if we simplify this, we get radical 25 times radical 2. And as soon as we do one more step, we get 5 radical 2. That's the pattern that we're going to have. So check out this pattern. We have 5, 5, 5 radical 2. Let's come up with the pattern for any 45, 45, 90 triangle. So let's call the bottom side N. Are you ready? It's a mathematical motto. I want to make sure you're ready. Here it is. Show me the pattern. Does it make you feel good to say it? Show me the pattern. Show me the pattern. No, not show you the pattern. Show me the pattern. Show me the pattern. I love trigonometry. All right, let's try this out on some other ones. First of all, how do you know for certain that you have a 45, 45, 90 triangle? They don't have to give you all the angles. If they simply show you that you have an isosceles triangle that's right angle, those would have to be 45, 45, 90. Also, if they gave you just one 45 degree and one right angle, you could use triangle equals 180 to prove that the other side is 45. If they gave us two 45 degree angles, the third missing side using triangle equals 180 would have to be a right angle. So they don't have to give you all the complete angles to know that you have a 45, 45, 90 triangle. All right, let's practice some. So what if I give you just one side? I tell you that side is 8. Show me the pattern. 8, 8, 8 radical 2. Let's try another one. What if I tell you the side is 27? Show me the pattern. 27, 27, 27 radical 2. This is getting easy. Let's try another one. What if I say 89's over there on the right side for one of the legs? Show me the pattern. 89, 89, and 89 radical 2 for your hypotenuse. Now, there's two ways that we can make this difficult. Help me to help you. So pay close attention to this. What if I show you that the hypotenuse is 10? This is not going to be an easy problem because we'd rather see a 10 radical 2, but we just have a 10. But let's move this up smaller so we can work on it. Let's call that leg N. And if we follow the pattern, the legs are N. And then notice that the 10 is where we have the N radical 2 part of the pattern. So we just have to let N radical 2 equal 10. So now let's solve that. Divide both sides by radical 2. And we get 10 divided by radical 2, which we want to simplify because we don't want radicals on the bottom. So multiply both sides by radical 2. We're left with 10 radical 2 over 2. And you can actually reduce that 10 and that 2 and get a final answer of 5 radical 2. So in this situation, 5 radical 2 would be the two missing sides that are legs. All right, let's try another one that's difficult. Go ahead and, if you want, pause the video and try this one on your own. All right, so once again, we don't have what we'd like to have. We have a whole number for our hypotenuse. There's no radical 2. So the other legs can be n. That means 7 is equal to n radical 2. And we can set that up, divide both sides by radical 2, and then we just have to, they cancel out. We have to go ahead and simplify our 7 divided by radical 2, multiply by radical 2 over radical 2, and we get 7 radical 2 over 2. This time we can't simplify the 7 and 2, so that is the length of both of your legs. All right, I told you there was 2 things we can do to make this more difficult. So the first one is to give you the whole number when you expect a radical 2. The second way to make special right triangles difficult is to give you a second pattern. Time for practice problems. So when you see the problem, pause the video, work it out, and then press play to check your answer. First problem. Okay, since this is an isosceles right triangle, those 2 angles would have to be 45 degrees. So it's a 45, 45, 90 triangle. And if we use x for our leg up there, that means our hypotenuse is x radical 2. This is the one that's a little harder to do. You set up x radical 2 equals 64, divide by radical 2. But then when you simplify by multiplying by radical 2 over radical 2, you get 64 radical 2 over 2. And the 64 divided by 2 can be simplified. X is 32 radical 2. And y is going to be the same thing, 32 radical 2. All right, last problem. All right, we're missing a right angle here, but since the other 2 angles are 45 degrees, the missing angle would be 90. All right, this one's another quick, easy problem. It follows our pattern. If we let the 19 equal n, then the y is equal to n, and the x is equal to n radical 2. So x is 19 radical 2, and y is simply 19.